Okay, hello and welcome to discussion 9. We're going to talk about light fields today. So first let's talk about how we parameterize light fields. Normally when we take a photo, we are receiving these rays from our environment. So let's say we have all of these rays coming from our focal plane. They bounce through our lens. They go through this plane here, we're just going to call our lens plane, and then they hit somewhere on the sensor. And then we can kind of denote the position of each of these rays by these UX coordinates, where X is the point on the focal plane that this ray passes through, and U is the point on the lens that the ray passes through. So for a normal 2D photograph, we actually don't record this U value at all. We just take some rays that start at some X point on our focal plane, and when the rays bounce through our lens, they all kind of converge at one point on our sensor, and we don't record like where these rays hit on our actual lens plane. For a Planoptic camera, we're actually going to keep track of this U coordinate, or kind of estimate it. So if you can see over here, we can differentiate the U value for rays. Not exactly, but to like in some range we can differentiate them. And that is due to this special thing called a microlens. It comes after all of the lenses and just right before the sensor, and it's kind of this like bumpy lens that will split apart these rays so that let's see, so let's look at all these rays. They come and they hit the sensor at one spot. A microlens would be right before this sensor, and it would just kind of separate these rays so that they hit different spots on the sensor, and then we can actually determine the U value from the spot that they hit on the sensor. So this lets us do a lot of cool stuff like aperture adjustment and depth refocusing. There's a lot of cool examples in the lecture, so if you haven't watched that, you definitely should. Let's go on to